Hi everyone, my name is Hussein, and for my computer graphics final project, I combined two interesting areas of research within computer science, and that is computer graphics, of course, but also machine learning. And so what I created was a 3D visualization of a neural network. And so if I launch it here and pull this over, you can see we have a very small, very simple 4-layer deep neural network. And this is actually a handwritten digit recognizing network. It's trained on the MNIST data set of handwritten digits. And the interesting thing about this visualization is that we can see, the colors and the weights give us a good idea of what's going on. So the neurons are represented in this example with these spheres, and so over here on the left, this is the input layer. So you can sort of make out the number 7 that we're predicting here in the input layer, and there's 2 intermediate layers, and finally we have 10 neurons in the output layer that represent the 10 classes or the 10 possible handwritten digits. And so the colors here give us a clue of how this neural network is working. So brighter colors, brighter reds represent negative activations, and brighter greens represent positive activations. And the darker colors there represent neurons that are not being activated as much. And in between the neurons, we can see the lines that actually represent the weights of the model. So the thickness of the line here actually corresponds with the weight of that particular connection in the model, and the color of the line is the activation. So similar to the neurons, green equals a positive activation and red equals a negative activation. And a few of the features of this visualization, we can actually click to move around and pan around the model. We can zoom in and out with the scroll wheel, and we can move around and sort of take a closer look at things and see how everything's working. So using the number keys on the keyboard, I can switch between 10 different samples. So for example, we're currently looking at number 7, and I can switch to predicting number 2, which this gets right, and it gets almost all of them right. But if we go all the way to number 8, it actually doesn't get this one right. It gets confused between, it looks like 4, 5, and 6. And yeah, so maybe a larger network could predict that, but I think this network does a pretty good job, and it's very interesting to see how the layers are connected and how the data is processed as it moves through the network. Thank you.